right. Let us proceed. Let us proceed with our previous discussion, where now I want us to talk about example 4 and 5 in this section, so that we can be able to proceed from that, so that at least someone can understand this area of trigonometric ratios. Now we have another example here where it's saying that given that sine x plus 60 degrees is equals to cos 2 x. Find tan x plus 60 degrees. Find tan x plus 60 degrees. So in this case, I want us to approach it in a different dimension, in a different technique, in a different method, so that at least you can understand, because this one offers a whole different package of our previous discussion. So in this case, we have sine, or given that sine is equals to x plus 60 degrees equals to cos 2x. Find tan x plus 60 degrees. Now, it's very good for us to go back to the initial discussion of our triangle. Now, having our triangle, this form, having our triangle here, we have a triangle. And in this case, we agreed that if this is a perpendicular angle, if this one is a perpendicular angle or a right angle, it means that these two angles are complementary angles. These two angles are complementary angles. So if suppose this one is x degrees and this one is y degrees, we agree that x and y are complementary angles. X and y are complementary angles. X and y are complementary angles. Now, we agree that x and y are complementary angles, meaning that both add up to 90 degrees. Both add up to 90 degrees. So in this kind of a scenario here, when we have this scenario where we have x and y, I want us to use this concept of x and y in this equation. So here we are going to have, let me use the question the way it's supposed to be. So in this case, we already know that if x and y are complementary angles, it means that now this angle and this angle are complementary angle. Remember that if this is 90 degrees, this one and this one is 45 degrees, we can also say x degrees is equals to y degrees. But now, sometimes they are not equal. Sometimes they are not equal. But again, it's very important for you to understand that sine theta, for example, theta, suppose we have theta here, sine theta is supposed to be given by, let's say this one is A, B, C. This side A, B, and C. So sine theta is supposed to be given by opposite, which is A, B, all over hypotenuse, which is AC. Then when you talk about cos theta, it's important for you to understand that cos theta, the same angle, talking about the same angle, it's very important for you to understand that cos theta is supposed to be given by adjacent BC all over AB. But suppose now we talk about the sine of this angle, theta 1, and we talk about theta 2. I want us to talk about, this is theta 1, this is theta 2. You understand that theta 1, this is the way we get sine. How do we get cos of theta 2? Theta 2 is given by cos theta 2 is given by adjacent again all over hypotenuse. Adjacent again all over hypotenuse. So when we talk about these two angles, you realize that this is theta 1, this is theta 2. But the values of theta 1 and theta 2 are equal when you use different ratios, where we are using sine and the other one we are using cosine. Very well. Now, in this case, you're talking about sine x plus 60 degrees equals to cos 2x. It means the theta is the same, or we have theta 1 and theta 2, getting the values of theta 1 and theta 2 using different ratios, where in one is given by sine, the other one is given by cosine. So it means that sine x plus 60 degrees, is equals to cos 2x. meaning that both of them, theta 1 and theta 2, are complementary. Theta 1 and theta 2 are complementary angles. Both of them add up to 90 degrees. So in this case, how to solve this one? We already know that if you take x plus 60 degrees plus 2x should give you 90 degrees. But before we do it this way, suppose we do it this way. Suppose we say x plus 60 degrees equals to 2x. Then we create an equation where x plus 60 degrees minus 2x equals to 0. However, it is very important to know that this one is a normal equation and this one cannot help us get the value. How do we get the value of x? We get the value of x by taking x plus 60, sorry, x plus 60 degrees plus this one. When it comes to this side, you don't subtract because it was added. You should know that both of them should add up to 90 degrees. So x plus 60 plus 2x should give you 90 degrees. Then from here, we put the like terms together, where we are going to have x plus 2x plus 60 degrees is equals to 90, where we are going to have 3x and 60. So in this case, allow me let me rub this one. I'll rewrite it again. So we have 3x plus 60 degrees equals to 90 degrees. We have 3x plus 60 degrees equals to 90 degrees, where we are going to say 3x is equals to 90 degrees minus 60 degrees, where we're going to have 3x is equals to 90 degrees minus 60 degrees, which is supposed to give us 30 degrees. Very well. Then from here, we divide both sides by 3. Where we are going to have x equals to 10 degrees. X equals to 10 degrees. X equals to 10 degrees. Now, what is the value of tan? What is the value of tan x plus 10? What is the value of tan x plus tan x plus 10? You can even put the value here and say we are going to have tan into 10 plus 60, where we are talking about tan of 70 degrees. And using a calculator, you are going to get the actual value. Using a calculator, you are going to get the value of tan 70 degrees. So use a calculator. Use calculator or the mathematical table. To get tan of 70 degrees. That is one. Now let me use the same techniques to get the value, or the other example that we had written here. We had two examples that we wrote. Let me talk about, this is example 4. Let me talk about example 5. Let me talk about example 5. It is advisable to pause and follow. So let us talk about example 5. When we are talking about example 5, in this case, we are told solve the equation where sine a half x minus 30 degrees is equals to cos x. Now this one is simple because we are going to use the ideology that we have brought on board here, where we know that now both of them are complementary because we agreed that theta 1 and theta 2 should add up to 90 degrees and they complement one another. So in this case, we're going to have a half x minus 30 degrees plus x should give you 90 degrees. Where we put like terms together, we are going to have a half x plus x minus 30 degrees is equals to 90, where we are going to have 1.5 x is equals to 90 degrees plus 30 degrees, where we are going to have 3 all over 2 x is equals to 100 120 degrees. 120 degrees. Then to get the value, we divide by 3 over 2 here. We get the value of 3 over 2 here, where we can multiply by 2 all over 3 that side, 2 all over 3 here. We cancel. We are going to remain with x, where by 3, 1 by 3, 4. So in this case, we're going to have 40. 40 multiplied by 2, we are going to have our x as 80 degrees. We are going to have our x as 80 degrees. So the value of x here is 80 degrees. So that is how we use trigonometric ratios. We go back to the complementary aspect, to equilateral aspect, so that we can get the value. So it is very important for you to keep on revisiting each and every part so that you can have a better understanding. Otherwise, have a nice evening. Thank you.